So we're jumping into Unit 3, okay? And on Unit 3, we actually already covered this before going. On Unit 3, we're going to learn how to graph linear functions that are in function form. But just a quick intro, we've already talked about this before. If we look at the equation x plus 1 equals 3, what must the answer be? What plus 1 equals 3? What does this have to be? 2, right? It's nice and easy. 2 plus 1 equals 3. It can't be 3. It can't be -2. It can't be any other number except x equals 2. 2 plus 1 equals 3. That's it. But when you have x plus y equals 3, then you really do have an infinite amount of answers. It could be 2 plus 1. It could be 3 and 0. It could be 0 and 3. It could be 4 and -1, 5 and -2, 6 and -3, 7 and -4, and so on and so on. You guys know that, right? Okay. So this is the reason why we graph functions, why we graph anything for that matter. When you graph, the graph actually represents the infinite amount of answers that exist to the equation. So just to give some answers off, again, we said like 1 plus 2, x could be 1, y could be 2, that'll give me the answer 3, or it could be 2 and 1. It could also be 3 and 0, or 0 and 3, right? 0 plus 3 is 3. It could also be like 4 and -1, could be 5 and -2. You could also switch those, and we know that it goes on forever and ever and ever. So if we actually, because we have these copies, let's all graph 1, 2, 1 on the x, 2 on the y, put a dot right there, and then go to the coordinate 2 on the x, 2 on the x, 1 on the y, 2 on the x, 1 on the y, put a dot right there. And then you could continue to graph all these points, and it will end up being a line. By the way, lines, how many points do we actually need to graph a line? 2. So technically, I have my line right here, and I could use the pattern from this point to this point to continue extending my line. I could say go down 1 over 1, down 1 over 1, that'll be that next point right there, and that next point right there, and that next point right there, which in reality, that's what I would get if I actually plugged in 3, 0, 3, 0. I mean, if I graphed 3, 0, there's 3 on the x, 0 on the y, 4, -1, 4 on the x, -1 on the y, 5, -2, 5 on the x, -2 on the y. So you could plug in numbers, but once you actually have 2 points of a line, and we know that this is a line, you could actually use the pattern between your points to extend it in both directions as far as you want. Okay. So once you have your graph, you put arrows on it because those arrows represent the infinite amount of answers that exist. For example, I know that x could be like 10 as long as my y is -7, right? 10 plus -7 is 3. So if I did go 10, this is 5, go out here to 10, then go down to -7, it will be perfectly on that line, okay? Because of the arrow, it does represent the infinite amount of answers that exist to that original equation. As you could see, all the solutions, the coordinates, they line up perfectly to form a line, and we only need 2 points. So right here it says how many points do we actually need? 2 points. That's all we actually need for a line. And then once you know it's a line, once you know you have those 2 points, you could use the pattern to extend the line in both directions. Anyway, here are the notes for today's lesson. The main vocab word phrase that we want to learn today is function form. And again, we've already talked about this in the past, but I want to reiterate it right here. Function form, it simply means get y by itself, okay? So we have equations, all these equations, 6 equations down here, and if they tell us rewrite the following equation in function form, that means simply get y by itself. Solve for y. Isolate y on one side. So it all means the same thing. Get the y by itself on one side of the equal sign. So the y is clearly on the left side of this equal sign. I don't want this +2. I want to get rid of it. What do I do? -2, right? So let's get rid of that +2 by subtracting 2. And of course, 2 take away 2 cancels out. I have y by itself. Y equals, now I can't do 3x take away 2. That's like saying I got 3 bananas and I want to take away 2 apples. That doesn't make sense. You could only rewrite it. And we always want to rewrite the x term first, the variable term first, and the number that's by itself second. So I would rewrite this as 3x minus 2. And ladies and gentlemen, this is now what we call function form. Y equals 3x minus 2. Now, again, a function is like a machine. When you have it set up like this, it's really easy to plug in inputs into your x's and pull out outputs, which are your y's. But anyways, on this section right here, all we're really practicing is how to rewrite an equation in function form, which simply means to solve for y, to get y by itself on the left side of the equal sign, to isolate the y on one side, especially the left side. So number 2, I want to get that y by itself. What do I do? Add 3 to both sides. Okay, so let's go plus 3, and we are talking about x's, so let's add 3x, add 3x. And yes, these cancel out. I now have a y by itself, and that's what function form is, getting y by itself. I can't go 4 plus 3x. I can't really add those, so I'm just going to rewrite it. But the best order to write it in, as previously mentioned, write your x term first, and then your constant, your number, by itself second. So I'm going to write it as positive 3x with a positive 4, 3x plus 4. Here is your function form equation. Are we good? Number 3, I need to get y by itself. What do I do?
Divide by 2.
Yep. I don't want this multiplication of 2 right in front of the y. I want y by itself. That's what function form means. So we're going to divide by 2, so it'll cancel out. But whatever you do to one side, you have to do to the other side. In other words, the entire side. So you're going to divide everything by 2. Okay. Now we know that, 2 divided by 2 is 1. That's why it cancels out. You just bring down the y. Right here, 2 divided by 2 is 1. You could put a 1 if you want, but you don't have to put the 1 in front of the x. So you could just say y equals x. And then last but not least, 6 divided by 2 is 3. So that would be a minus 3 right there. There's your function form equation. Y is by itself. Y equals x minus 3. Or technically, you could also say y equals 1x minus 3. Are you with me? Okay. Let's move on. Number 4. That one's so easy that you might get confused. Is y by itself almost?
No. You have to turn it into a positive.
You got to turn into a positive. So how could you turn into a positive? You could either multiply everything by -1, or you could divide everything by -1. Now, a lot of people like to divide because you really have a -1 right here in front of the y. That's really a -1 times y. So you divide by -1, divide by -1, divide by -1. But the bottom line is it's going to just change all the signs. It's going to be the same equation, but instead of a -y, it's going to be a positive y. Instead of a positive x, it's going to be a negative x. Instead of a -5, it's going to be a +5. And there's your function form equation for number 4. Believe it or not, there will be some easy questions like this on the quiz this Friday, where I just give you an equation and I say rewrite it in function form. Oh, that just means get y by itself. Number 5, I want to get y by itself. What do I do?
Divide everything by 5.
That's exactly right. We do have a multiplication of 5 in front of the y. We don't want that. Let's divide by 5. And what I do to one side, I do to the entire other side. Divide everything by 5. Now, we do know that the 5s cancel out. We end up with a nice, beautiful y all by itself. And this one's easy. 10 divided by 5 is 2. And of course, you have a minus sign in front of it. And over here, this guy, you can't divide 4 by 5. And that's okay. We're just going to leave it like a fraction. We're going to write it 4 over 5. And the x, I'm just going to put it right next to the fraction. Instead of leaving it up on top with the 4, I'm going to put it right next to the fraction. So this is function form. But it's better to write it with the y on the left side and this stuff on the right side. So let me rewrite it with my y on the left and the 4/5 x minus 2 on the right. And there's my function form equation. Y equals 4/5 x minus 2. This one is pretty much done for you. It's so easy, you might get confused. Function form means get y by itself. Isn't y by itself already? Yeah, it is. The only thing you can do to make it look a little bit nicer is to do what?
Make an x turn to 1.
Yeah, put the x first and the 1 second, right? It's always nicer to have your variable term first, that positive x, and then write that positive 1 second plus 1 second. So that's function form right there. So there will be some questions on the assessment this week that I ask you to write in function form, and you need to know that function form means simply get y by itself. Solve for y. Isolate y on one side. Anyway, up here we have our steps to graphing a 2-variable equation with this function form, right? Step 1 is to rewrite in function form. That means get y by itself. So a lot of these will already be done for you. If we look at this guy, it's already in function form. Y is already by itself, so you don't have to do anything for step 1. Step 2 is make an input-output table, an XY table, and plug in 3 easy numbers, most of the time 0, 1, and 2. Maybe right here, right next to step 2, maybe we should draw an actual input-output table and plug in 0, 1, and 2. Now, that's not always going to happen where we use 0, 1, and 2, but most of the time, when you don't have a fraction in front of x, it's a great idea to plug in 0, 1, and 2 for your inputs, do the math, and get your outputs. Let's actually show that on number 1. So step 1, rewrite it in function form. That's already in function form. Step 2, make an input-output table. So everybody right next to number 1, let's do a little input-output table. Remember, the inputs are the x's, the outputs are the y's. Now we're going to plug in 3 easy numbers, and right here we wrote 0, 1, and 2. So we could do 0, 1, and 2. Let's start with 0. And I'm going to do this in my mind. Hopefully you're able to follow along. You see, when I input 0 into my x, here's x. If I put a 0 right there in my mind, in our minds, what is negative 2 times 0?
0.
And what is 0 plus 1?
1.
So my answer is 1. Let's understand this. I plugged in a 0, and I got out the answer 1. My x value is 0, my y value is 1. My domain is 0, my range is 1. Those are just all different words that mean the same thing. Anyway, how about plugging in 1? Let's do this in our minds right here. Plug in a 1 right there into x. What's negative 2 times 1?
Negative 2.
And what is negative 2 plus 1? Negative 1. So there's your coordinate. When you plug in a 1, you get out a negative 1. Okay? And you know what? You could plug in a 2 if you wanted to, but you actually only need 2 points. Check it out. 0, 1 and 1, negative 1. Let's actually graph 0, 1. That means 0 on the x. You stay there at the origin. 1 on the y. Put a dot right there at 0, 1. And then go to your next coordinate, 1, negative 1. 1 on the x, negative 1 on the y. So from the origin, 1 on the x, negative 1 on the y, and put a dot right there. Now, those 2 dots is enough for us to draw our line. However, if you wanted to make this line longer, yes, you could plug in more numbers, but you could also just analyze the pattern of these 2 dots from the left one to the right one. I'm going down 2 over 1, so I could use that pattern of down 2 over 1 to get to this next coordinate. By the way, what is this next coordinate right here? Could somebody tell me that location? That's 2 on the x and negative 3 on the y, huh? Now, what does that mean? That means that if I did actually plug in a 2 right here, I will get a negative 3 for my y value. Don't believe me? Let's do the math. Plug in a 2 right there. Negative 2 times 2 is negative 4, and negative 4 plus 1 is negative 3. So you don't have to do a lot of math. Once you have your 2 points, you could just use the pattern from your points going down 2 over 1, down 2 over 1, and you get to the next point. And you could even go down 2 over 1 again to get to this point right here. What's that location, guys? On the x, what is it? 3 and negative 5, right? So this point right here, I'll do it in blue. That's the coordinate 3 comma negative 5. That means if I did plug in a 3 over here into the machine, it would come out a negative 5. So you don't have to do that math. You could just use the pattern to extend the line however far you want to extend it. Down 2 over 1, down 2 over 1, down 2 over 1. You can even go backwards, over 1 up 2, over 1 up 2, over 1 up 2, over 1 up 2, and put a dot right there. And over 1 up 2 and put a dot right there. But you are right that the pattern that I'm actually talking about in the future, in a week, we're going to define it as slope, right? Rise over run. But right now, I just want to talk about, like, logically, oh, there's a pattern from this point to that point. It's going down 2 over 1, down 2 over 1, down 2 over 1. You could use that pattern backwards to extend the line as far as you want. So you could actually make it all the way up here and all the way down here. Anyway, that's how we graph. You really only need 2 points, and then after that, you could use the pattern of those 2 points to extend it. Number 2, is it in function form? Yes, it is. So step 2 is to go to an input-output table. Now, it says that most of the time, especially like up here on our notes, we put 0, 1, and 2. It says most of the time we're going to use 0, 1, and 2, but in this case, we're not. Okay? Whenever you have a fraction in front of x,
Can't you use 0 for this one?
Yeah, we're always going to use 0. 0 is always the easiest value to use. When you plug in 0, I mean, that's beautiful because anything times 0 is 0. So let's do that math right here. Plug in 0, anything times 0 is 0. 0 minus 2 is what? Negative 2. So that's super, always use 0. 0 is great. Okay, so 0, negative 2. Here's 0, negative 2. Let's actually put that dot. Now, the next number that we're going to use is going to be the denominator of the fraction in front of the x. Because if we actually use this number, it's going to cancel out. So if I have 1/3 times, let's say x is 3, it's going to cancel out. So I might as well use the x value of 3. That way when I do plug it in, it's going to cancel out. Let me actually show that here. I'm actually going to show my work. 1/3 times, I'm plugging in a 3 in place of this x. And then we have minus 2. And when I do the 1/3 times 3, that does cancel out. What do I have left? I have a 1 minus 2. 1 minus 2 is negative 1. So when I do plug in a 3, I will get out the answer negative 1. Negative 1. And that's your next coordinate. Let's actually go to 1, 2, 3 on the x, negative 1 on the y, and put a dot right there. So we know that 2 points is all we really need. Okay? Now, yes, if you wanted to plug in more x values and do math, I would double the denominator and maybe use 6. Or I could also use the negative denominator because that would still cancel it out, but it would just change your sign. But in reality, once you have those 2 points, you could use the pattern from this point to that point. What are you doing from the red dot to the blue dot? You're going up 1 over 3. So if you wanted to, you could use that pattern of up 1 over 1, 2, 3. You're going to be 1 unit off the graph. But even if I'm 1 unit off the graph, what is that location of this black dot right here? What's that location? 6, right? 5, 1 unit off is 6, and 0. So if I did plug in 6, what would I get out? A 0, right? But it's a lot easier to get those inputs and outputs by using the pattern of those 2 points. That is, if you're confident that you didn't make a mistake with these 2 points, which I hope we are confident that we didn't make the mistake. So I did go up 1 over 3, up 1 over 3. I could go backwards, over 3, down 1, over 3, down 1, over 3, down 1. And what would that location be? That'd be negative 3 and negative 3, right? So if I did plug in a negative 3, what would I get out? A negative 3. You see, the coordinates are really all the infinite answers that exist to an equation. So anyway, here's my line. I could point it at that black one. And that's how you graph. It's pretty simple, especially if they're already in function form. Number 3, so easy that you might get confused. Okay, let's think of this. Is it in function form? Yes. If I wanted to go to input-output table, what numbers could I use?
0, 1, 2.
0, 1, 2. Okay. I mean, you could use any numbers you want, but most of the time 0, 1, and 2 are easy. Now, if I did plug in a 0 into x, what would it say? It would say y equals 0, so your y would be 0. What if I plugged in a 1, what would it say? Y equals 1, which means that it's a 1, right? Now, actually, let's think of this logically. This equation says that your y values have to be your x values, which means your x values have to be your y values, huh? So whatever x is, y has to be the same thing. So you have 2 right here. What's the y have to be? 2. How about negative 3? What does the y have to be? Negative 3. They have to be equal to each other. So you could do this, you could do this as many points as you want. Negative 1, 2, 2, 4, 4. As long as your x is equal to your y and your y is equal to your x, you're good to go. After all, there's an infinite amount of points to these lines. But you only really need how many points? 2. 0, 0, that is right here, and 1, 1, that is right there. And if you wanted to, you could use your pattern from these 2 points. Up 1 over 1, up 1 over 1, and put a dot right there. And continue to go up 1 over 1, up 1 over 1. And you could use that pattern backwards, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, to get to that point right there, and so on, extending it this way. The bottom line is, this is the line, whoops, went a little crooked there. There's your line for y equals x. How does that taste? Tastes good. Finally, we have an equation that's not in function form. Okay, Okay, so let's get it in function form. I need to get y by itself. What do I do?
You add 8.
Let's first get rid of the 8. Yeah, let's first get rid of the 8 before dividing by 2. So yeah, subtract 8. What do I have? I have a 2y left over on the left side of my equal sign. And of course, x take away 8, I can't do that. So I'm just going to rewrite it exactly the way it is. X take away 8. Now, just for funsies here, what number is in front of x?
1.
An invisible 1, right? And you know what? I might as well write an invisible 1 right there, especially because my next step here is to divide by what?
2.
To get y by itself, I need to get rid of this multiplication of 2 by dividing by 2. Dividing by 2. So y equals 1 over 2, you just leave it, put the x on the side, and 8 divided by 2 is 4. So there is your function form equation, y equals 1/2 x minus 4. Okay? Now, let's go to an input-output table. 0 always works. 0 is beautiful, right? Let's do that. Let's use 0 for the input. When I plug in a 0 into this x, anything times 0 is 0. And 0 minus 4 is what? Negative 4. So everybody, when we plug in a 0, we get out a negative 4. That is a coordinate. Let's actually graph 0, negative 4. 0 on the x, negative 4 on the y. There it is. Okay. And now let's plug in another point. What other point should I plug in? The denominator of the fraction, which in this case is 2. Whenever you have a fraction, you don't want to just go 0, 1, and 2. Look at whatever that denominator is and use it. So the denominator is 2. I'm actually going to plug in a 2. Okay, so I'm going to plug in a 2 into my x, and that fraction will cancel out. Okay, let me actually show my work. I don't really have enough space. Where could I show my work? I guess I'll do it up here. Y equals 1/2 times x, and we know that x is 2, and then minus 4. All I did was rewrite this, but I put parentheses instead of x. There's my parentheses, and I plugged in the x value of 2. Doing the math, 1/2 times 2 cancels out. What I have left is y equals 1 minus 4, which means that y equals what? Negative 3. Thank you very much. So that's my second point, 2, negative 3. 2 on the x, negative 3 on the y. 2 on the x, negative 1, 2, 3 on the y. Let's put a dot right there. Right there. So those are my 2 points. Yes, I could plug in more values. If I wanted to, I could plug in an x value of 4 and do the math and get my answer. I could even plug in the x value of negative 2, do the math and get my answer. Or, since I only need 2 points to draw a line, I could use the pattern between these 2 points. That would be going up 1 over 2 and continue that pattern up 1 over 2 and put your dot right there. What is that location of that black dot? Anybody? What's that location? 4, negative 2. That means that if I were to have my x value of 4, what's my y value? Negative 2. If I were to actually plug in 4 into here, 4 times half is 2, 2 minus 2 is negative 2. So you could use the pattern of your 2 dots instead of doing more math. It's totally up to you. I could plug in a negative 2 right here, do the math, and get my answer. Or I could use the pattern of going up 1 over 2, but backwards, over 2, down 1, over 2, down 1, and put a dot right there. And what is the location of that black dot right here? Negative 2, negative 5. That means if I put in a negative 2, what am I going to get out? Negative 5. And again, believe me, if you don't, go ahead and plug it in. Negative 2 plugged in right here. Negative 2 times half is negative 1. Negative 1 minus 4 is negative 5. So you could do the math on all the points you want, or with 2 points, you could then use the pattern from one point to the other to extend the line as far as you want. So this is what this line looks like. And in reality, you don't need to do 4 dots like this. All you need is 2 dots and draw a line through it and you're good to go. I do recommend doing 3 dots though. Anyway, a couple more details in our notes today. When you have x equals a number, it's going to be a vertical line. That means a line going up and down, crossing the x-axis at that value. Okay? So anytime you have x equals a number, you're going to go to that x-axis. you're going to go to the value of negative 3, and you're going to draw a vertical line right through it. So let's go to negative 3, put a dot at negative 3, and just draw a line going up and down right through that x value of negative 3. Again, anytime you have a x equals a number equation, it's going to be a vertical line crossing the x-axis at that value. Anytime you have y equals a number, like right here we have y equals a number, it's going to be a horizontal. What's horizontal? It's not up and down, it's left and right. Okay, it's left and right. It's going to be a horizontal line, left and right, going right through the y-axis at that value. So I'm going to go to the y-axis, I'm going to go to the y value of 2, and I'm going to draw a horizontal left and right line right through it. And it's that easy to graph these, right? Now, you could memorize these facts that when you have x equals a number, it's going to be a vertical line going right through that x value. So if I had x equals positive 2, you'd go to 2, you'd draw a vertical line right through it. X equals positive 4, right there. X equals negative 5, right there. Vertical line right through x and negative 5. Or x at the value of negative 5. Or, let's say you totally blanked out and you forgot those facts. What is the only thing that this equation actually says? What does it say? Somebody read it to me. X has to equal negative 3. Is there any y values in there? No. So who cares about y's? On your input-output table, the only thing that this cares about is that your x values are negative 3. So you just write a bunch of negative 3's on the x. What about your y's? Who cares? There are no y's. You could put in whatever you want. You could put a 0, you could put a negative 2, you could put a positive 3, whatever you want. And you will get coordinates. Let's do that first one. Where is negative 3, 0? Negative 3, 0 is right there. That dot right there. Let me do it in green. This coordinate right here, negative 3, negative 2. Negative 3, negative 2, it's going to be that dot right there. If you go to negative 3, positive 3, negative 3, positive 3, you can get a dot right there. And of course, what kind of line is that going through those 3 green dots? It's a vertical line. So even if you forgot that fact and you stuck with your input-output table and you realize that this equation, all it cares about is that your x values are negative 3, put a bunch of negative 3's on your x side, put whatever you want on your y side, and those will give you coordinates that produce a vertical line going right through that x value of negative 3. Yay? All right. Next one, same deal. You don't have to remember that y equals a number is a horizontal line. You could just go back to your input-output table, and the only thing that this cares about is that your y values are 2. 2, 2, 2, 2, whatever you want on y. What about x? Are there any x values here? No. So you could put whatever you want for x. Yeah, you could do 0, 1, and 2. You could do negative 4, whatever you want. Right? Now, if you look at these coordinates, 0, 2, 0 on the x, 2 on the y, that's going to be right there, 0, 2. If I go 1, 2, 1 on the x, 2 on the y, it's going to be right there. Obviously, that's a horizontal line. 2, 2, 2 on the x, 2 on the y, that's right there. Horizontal line. Negative 4, 2. Negative 4 on the x, 2 on the y, it's a horizontal line.
So we'll never stop being horizontal?
Whenever you have y equals a number, it's going to be a horizontal line.
But it's never going to stop being horizontal?
It's never going to stop being horizontal. If you just have y equals a number, it's going to be a totally flat line. If I had y equals negative 3, that'd be at the negative 3, totally flat. If I had y equals negative 5, you go to negative 5 on the y, totally flat. Now, if it was x equals, we said x equals produces a vertical line. Y equals a number produces a horizontal line. All right, almost done. Actually, we're going to hold off on this till later. We are done with our notes. Let's jump to actually practicing some of this. So we have this page of practice, and I would let you go, but right now I know a lot of people are going to be like, what the heck is that, f times x? No, it's not f times x. That's what we call function notation, okay? It could be f of x, it could be g of x, it could be h of q, it could be any 2 letters. And this is just the name, and most of the time, the name of the machine is y. Most of the time, y is by itself, right? But what I want you to understand right now is that f of x is the same exact thing as y. Okay, so maybe on number 2, go ahead and rewrite it as y equals negative 3x plus 4. Okay, so anytime you have an f of x, just replace it with the y. It's the same exact thing, right? Or any of those letters for that matter, like right here, g of x, number 6, that's the same thing. That's just the name. G of x is the name of this machine. Okay, so you could change it to y if you want to. Y equals 1/4 x plus 2. That way you don't get confused. Or like on the third one right here, that one just says g of h. So it's kind of like if this were a y and this were an x. All right. So actually, let's write that. Let's write it down as y equals x minus 2. So anytime you have h of x, g of h, or any of that stuff, that's the same thing as y. So this is y, and this is x. Okay. Anyway, once you have your equation in function form, then you could use an input-output table to find some points. You only really need 2. And then from there, you could use the pattern of those 2 points to find other answers. Shall we do one of them together, or let you work on it on your own? It's up to you. One together? Which one? Pick one. 6. All right. So we did say that g of x is the same thing as y. It is in function form. We now jump to an input-output table. Let's plug in some easy numbers. 0 is always amazing because when you plug in a 0, anything times 0 is 0. So what is 0 plus 2? What is 0 plus 2? 2. So again, when you plug in 0 right here, 1/4 times 0 is 0, and 0 plus 2 is 2. So the input 0 gave you the output 2. That is a coordinate. Let's graph it. 0 on the x, 2 on the y. That's that red dot right there. Okay. Now we need more inputs. What other input should I use? The denominator. What is the denominator of the fraction in front of x? 4. So use 4. Let's plug in 4 right in there. And I am going to show my work. I want to rewrite this as 1/4, but instead of x, I'm going to put a 4 right in there. And then, of course, I have the plus 2. I'm going to write plus 2 over here. And let's do the math carefully. The reason why we're using a 4 is because it cancels out, and you end up with a nice, beautiful 1 plus 2, which is 3. So when I plug in a 4, I get out a 3. And that coordinate, 4 on the x, 3 on the y, 1, 2, 3, 4 on the x, 1, 2, 3 on the y, put a dot right there at the location 4, 3. I'll do it in blue. Now, you could plug in more values like maybe 8 or like maybe -4, but you don't really have to. If you know you didn't make a mistake on these 2 points, from this point to that point, you went up 1 over 1, 2, 3, 4. So backwards, it'd be 4 this way and down 1. 1, 2, 3, 4 this way and down 1. You could put a dot right there if you wanted to. And that would extend the line in both directions as far as you want. But there's your graph. Now, if you do think about this dot that I came up with by, instead of going up 1 over 4, going backwards over 4 down 1, that's the location -4, +1. So the input -4 should give us the output +1, which it will if I actually did the math. But you don't have to do the math. Once you have 2 points, as long as you didn't make a mistake, you know that you could use the pattern from this point to that point, up 1 over 4, and you could use that pattern backwards, over 4 down 1, over 4 down 1, to extend it as far as you want. Anyway, this video is already way too long. There is a different video explaining, I think, most of these, and their answers are also on Google Classroom. Let's practice.